Good afternoon to all of my Adult Learning Center students. It is currently, I've lost track of time, but Saturday, April 11th at noontime on the East Coast. My name is Joe. If you stumbled across this video and are pursuing your GED and or high school equivalency diploma, I teach GED/HSC courses at New Brunswick Public Schools, and I am going to be creating a massive amount of content to support my adult learners and any foreign adult learners in their quest to obtain a high school diploma. We are starting with linear equations, and there'll be a series of videos put out that go through the entire scope and sequence. For my learners in particular. Okay, here is the link to register with our Schoology platform and the code that you would need to input in order to access the materials that I'll be utilizing moving forward. So I hope everyone's staying safe and healthy and that these videos are beneficial. If you have any questions or need any more support, feel free to send me an email or leave a comment below and I will comment back. Let's get into the math madness. All right, so we'll begin with equations. What are equations? Equations are simply, they are statements that demonstrate that two algebraic expressions are equal. Okay. All right, so we typically have a left and right side to just kind of denote or specify which side we're talking about in particular. And I should add as well, right, that equations, they involve the use of obviously numbers, operations, and variables, right? And if you've forgotten, operations include addition, subtraction, multiplication, and division. And a solution is simply a numerical value that can be substituted into an equation, or into a variable that will satisfy the equation. All right. Okay, first checkpoint. What is the difference between an equation and an expression? I'll type this for now. I have a pen I will use when we start to do more of the mathematics, right? But the biggest difference is the equal sign, right? So an expression is the previous unit, and videos will come out after the fact since this is the first one of this giant TASC math series. But an expression is nothing more than all you see above, right? Numbers, operations, and maybe some variables, but you cannot solve them, right? You can merely simplify them, right? So while I don't want to say that they don't have one answer, because they do, they don't have a numerical value for an answer, right? In an equation, our solution is precisely one numerical value. Whereas in an expression, the solution could be 2x plus 4, right? The final value, final answer. So notice, right, 2x, we have a variable, plus we have an operation, and 4, we have a number. So it's a statement. And listen, it might be 2, it might be 0, okay? Because that in itself is also a statement. But if we wanted to determine whether or not, as we get to checkpoint 2, whether or not these values are solutions, right? X equals 8. All we simply need to do is we need to substitute this value of 8 into the variable. So if we substitute 8 here, right, we can read this, and that's a big component, is we want to be able to read these in English, right? So 8 plus 7, that's going to give us a 15, okay, equals, now this piece here, terrible habit, I blame myself, right? And for those of you that have been back in the classroom, right, we'll just read this as 2x. But something that I always make a point to emphasize is anytime we say 2x, right, we don't use an operation. What operation are we implying? Right, a better way to describe this using English would be 2 times x. And 2 times x would indicate 2 times 8, and that would give us a 16. And evidently 15 does not equal 16, so this is not a solution. This is pretty thick. Let's see if we can scale this back a little bit. All right, now in the next one, right, I know it looks a little bit more intimidating because we have the use of an exponent, but same principle, right? We're going to take this value for 10. Much better. Right, we're going to substitute that in. Okay. Fortunately for us, we just need to see if this verifies and equals to 200. So I'm actually going to not write the right side of the equation. Okay. Now, we must be very careful here because it requires the use of our order of operations that we should have learned in Unit 1. So I have multiplication, since there's no operation between the 2 and the parentheses. But then I also have an exponent. And according to order of operations, we must employ our exponents before we multiply things, right? So that's what I'm going to do first. I'm going to circle that. Right, that's the first piece I'm going to do. So negative 10 to the second power, right? Remember, exponents are repeated multiplication, so that's going to be negative 10 times negative 10, which is a positive 100. But we still have the 2, right? So we have 2 times positive 100. And if you're a forward thinker, you can see that that value is equal to 200. So yes, solution. Right, I'm going to, as scriptive as my writing may be, and for those of you that miss it dearly, I'm going to try to limit how much I write, because writing on a screen or on a tablet with an electronic pen is just not the same. So before we dive into the nitty-gritty of equations, let's just talk about the proper verbiage. That way we can communicate effectively. I'll type this in. I'll write this in. Right, so blank blank are equations in which the variable appears only to the first power. Right, we call those linear equations. Not too shabby. Right, and linear, if you take a closer look, right, if I were to ask you what's the root word inside of there, we can clearly see the word line. Okay, so linear equations algebraically translate into lines graphically later. That'll come in about 3 or 4 videos from now. Okay. Before we get into solving any of them, though, we have to talk about a few key properties. Okay. So the way I like to think about equations are kind of like a scale, right? So if you have 2 sides to a scale and you put 5 pounds on one side, right, that should sink, and then the other side should go up, very similar to a seesaw. Okay. So when things are equal, we like them to be balanced, right? So if we were to have let's say we have an equation. If it'll allow me to type math. Oh, how pretty. Right. So let's say we have, I'll change that to B actually, right? A equals technical difficulties. If A equals B, right? So we have a left side of the equation equal to the right side of the equation. It does not matter what the left or the right side says, right? And we can get much more in depth here, but we're going to keep it nice and simple. Okay. Notice we're talking about the addition and subtraction property of equality. Then, okay, I can do addition to both sides of my equation so long as it's the same value, right? So notice, right, I added C to both A and C to B, right? So if I added 5 pounds on the left side of my equation, I must also add those 5 pounds. That way it's still balanced, okay? Or, right, and if you're using your intuition here, I could also subtract. Okay. So the cool thing that I like about equations is you can do whatever it is you want to do to them, so long as you do it to both sides. Now, I'm not saying that that's going to get you toward the answer, right? You might be going just down a rabbit hole completely in the opposite direction of what wherever you're supposed to be headed. Okay. But if you take a look at checkpoint 3A before we get into it, and you're like, I want to multiply both sides equation by 10 million, by all means, have at it. Go to town. Okay. Now, obviously, that's not going to be the most direct path, but I want to reiterate. Okay. You can do whatever you want to equations so long as you treat them equally. Okay. And something that I joke around with my high school students is, and maybe it's not necessarily a joke, but in the 21st century, unfortunately, we still live in a society where not everyone's treated equal. But I remember my mom always telling me, treat everyone how you want to be treated. So I want to make sure that whatever I do to the left side of the equation, I also do to the right. And if we were to reapply this same type of ideology to multiplication division, right? So let's say we have another equation. Right, A equals B, right? Left side, right side, doesn't really matter, but they're equal to one another. Then right, I could multiply both sides of the equation by the same value. Or I could, and yes, for those of you watching at home, I can hear what you're thinking. You could also divide, except with the division. I wonder if they have a symbol for this. Let's see. Symbol palette. Perfect. There you are. See, so if you're wondering what that symbol actually represents, let me get back to the math. Oh, there we go. Okay, this symbol here that I've highlighted, right, with the equal sign with a slash means does not equal. Okay, the golden rule of division is that you cannot divide by 0. Okay, just think about, I'm not going to get into the specifics here for video length purposes, but if you were to have a pizza that you wanted to distribute amongst 0 people, you will probably be sitting there scratching your head saying, well, how much does everyone, no one, it doesn't really necessarily work out, right? There's no one there. So who are you going to divide and distribute it to, right? So that's why, or a quick, real world application of why you may not divide by 0. Okay. But I'm going to pause my video here and create a part 2. But that will be the overarching introduction to linear equations. Like I said, if you have any questions, comment below or send me an email, or if you are a MBPS adult student, comment in the Schoology account. I hope this video was informative and you are staying safe and healthy, and see you soon.